adding 2D content to a WebGL context. And in the previous video we were able to create this black empty box, and you can check out this open demo in a new page. And by the end of this WebGL series, this is our final product. So this is our main objective. So we would like to end up with something like this. And to do this, I'm gonna go to my folder that I named games, and I'm gonna open it. So right click, open in terminal, and I'm just gonna type in code space that so I can open it in Visual Studio Code. And I only have two files, the index.html and the webgl-demo.js. so we have that up to this point. I'm gonna control tilde so I can have my terminal, my incorporated terminal here. So I'm gonna leave it like that, and I can close this terminal here. So okay, so this is our final product, and now we're gonna be dealing with a 2D content to a WebGL context. So once you've successfully created a WebGL context, you can start rendering into it. A simple thing we can do is draw an untextured square plane. So let's start there. To complete source code for this project is available on the GitHub, including the GL matrix library. This project uses the GL matrix library to perform its matrix operation, so you will need to include that in your project. We are loading a copy from the CDM node. Update your index.html so it looks like this. So we're gonna update it, our file in the VS Code. Okay, so we're gonna go into the HTML file, and let's see, we need to update it. So we just need to add this link. Okay, so we have the title is fine, the head. Okay, so okay, so we can just start pretty much work on it. So let's update it. So we are gonna have this, let me see, it's gonna be a link like that. We're gonna have this link, and okay, so we're gonna end it with a forward slash, and now we are gonna have an URL, and it's gonna be set to a style sheet. Okay, so it's gonna be a style sheet. Okay, so we have the link, we have the rel set to a style sheet. We're gonna have the href. Okay, so we're gonna have the href, and we are gonna set it to the, let me see, we're gonna set it to the web. We're gonna set it to the WebGL, and it's gonna be .cs. So we don't have it yet, but in future videos we're gonna incorporate it. So let's just add it for the time being. Okay, so we have the href is set to the /web. Okay, then we're gonna have the type. Okay, so we're gonna have in the type, and inside of the type we are gonna have let me see, we're gonna have text /css. So it's gonna be text. Okay, text /css. So we have that, and then the forward slash, and we close this arrow function. So that's what we have for the link. And let's open it with right click and then open with live server. So it's gonna send us, okay, so we have this big square. Now we're gonna continue with our code. So we're gonna go into, okay, so we added the link. Now we're gonna add a script. Okay, so we have two scripts already. Okay, so we have one script here. We're gonna have another script. Okay, so let's just go below here, and let's just add a script like that. We're gonna have this script here, and let me see, so we're gonna have this script, and it's gonna have the source, it's gonna have the integrity, it's gonna have the cross origin, and also the fur, and yeah, and then we have this script that is from the previous video that we just use it to connect it to the JavaScript. So let's move this script to the very end, and let's start working with this script. So I might just let's just copy this first. Maybe let's just copy this part here and let's put it right here. Okay, like that. And we can, okay, so we have that. So we're gonna have this script here, and we're gonna have a source, and the source we're gonna set it to this URL that is gonna be the cdn.js. Okay, for example, if I press Ctrl and then click, pretty much this is what it sends me. So as you can see, it's a bunch of code here. Okay, so this is the theme. Okay, so now we have that. We have also integrity, and we're gonna set it to pretty much this this code. We also have the cross origin, and we are setting it to anonymous, and then the fair. So we can just leave it like that for the time being, and this is inside of the script. And then we're gonna have the second script that is just pretty much pointing to the source, to this file right here, this WebGL -demo. So we have that. Okay, so we have updated it, so let's leave that here. Let's close this one. Let me see, let's close. Okay, so we have that. What else do we need to update? We have modified that, and yeah, that's pretty much all we need to update the index.html file. So we just needed to add the link and a second script. Okay, so web type module is the same, so let me see, type module, that's fine. Then we have the canvas. Okay, so now drawing the scene. The most important thing to understand before we get started is that even though we're only rendering a square plane object in this example, we are still drawing in 3D space. It's just we are drawing a square and we are putting it directly in front of the camera perpendicular to the view direction. We need to define the shaders that will create the color for our simple scene as well as draw our object. These will establish how the square plane appears on the screen. So the shaders. A shader is a program written using the OpenGL ES shading language, the GLSL, that takes information about the vertices that makes up a shape and generates the data needed to render the pixels onto the screen, namely the positions of the pixels and their colors. There are two shaders functions run when drawing WebGL content, the vertex shader and the fragment shader. You write these in GLS and GLSL and pass the text of the code into the WebGL to be compiled for execution on the GPU. Together, a set of vertex and fragment shaders is called a shader program. Let's take a quick look at the two types of shaders with example in mind of drawing a 2D shape into the WebGL context. So we have the vertex shader. Each time a shape is rendered, the vertex shader is run for each vertex and the shape. Its job is to transfer the input vertex from its original coordinate system into the clip space coordinate system used by the WebGL, in which each axis has a range from -1.0 to 1.0, regardless of aspect ratio, actual size, or any other factors. The vertex shader must perform the needed transforms on the vertex position, make any other adjustments or calculations it needs to make on a per vertex basis, then return the transformed vertex by saving it in a special variable provided by the GLSL called GL_position. The vertex shader can, as needed, also do things like determine the coordinates within the faces textures of the texel to apply to the vertex, apply the normals to determine the lighting factor to apply to the vertex, and so on. This information can then be stored in variants or attributes as appropriate to be shared with the fragment shader. Our vertex shader below receives vertex position values from an attribute we define called the a vertex position. That position is then multiplied by two 4x4 matrices. So this is linear algebra. We provide call uProject motion matrix and uModel view matrix GL underscore position is set to the result. For more information on projection and other matrices, you might find this article useful, so you can check out this link. Note: add this to your main function. So now we're gonna add some code. We're gonna add this code to our JavaScript file. So we're gonna start modifying now our JavaScript file, and let me see. Okay, so add this code to your main function. So we're gonna have the vertex shader program. Okay, so let's just copy. I'm just gonna copy this little part here. So I'm gonna have the vertex shader program, so like that, and we're gonna start typing. So we're gonna have this variable, so it's gonna be a constant. It's gonna be a const, and the name is gonna be vs lowercase, and then it's gonna be source, like that, source, vs source, and we're gonna set it to backticks, like that, and we are gonna end up this statement with a semicolon. Okay, so we have this variable named vs source. We are sending it to this backticks, and we're gonna start typing our code inside of this backtick. So let me see, what do we have here? So we're gonna have the attribute. We're gonna start typing attribute, like that. We're gonna have the attribute, and it's gonna be it's gonna be vec4, and then we're gonna have a, and it's gonna be v. Okay, it's gonna be vertex, a vertex position. So like that, in Kemo notation, position. We ended up with a semicolon. To the next line, we're gonna have uniform mat4. Okay, uniform mat4, and then we're gonna have u, and it's gonna be model, uModel view matrix, uModel, and it's gonna be a view matrix, and then we're gonna end up with a semicolon. To the next line, we're gonna have pretty much the same thing. So it's gonna be the uniform mat4, like that, and then it's gonna be uProject. It's gonna be uProject, and as you can see, we're using common notation, project, projection matrix. Okay, projection matrix, like that. Okay, so we have these three lines from 23 to 25, and then 24 we're gonna have in the void. We're gonna have in the main here, so it's gonna be the main. We're gonna open parentheses, we're gonna open the curly braces, and inside of the curly braces we're gonna have the GL underscore. So we have the GL underscore, and it's gonna have position. So GL underscore position, and we are gonna set it to something. We're gonna set it to the U projection matrix. So we're gonna set it to the U projection matrix. We're gonna set it to the U projection matrix, and we're gonna multiply by the uModel, the uModel view matrix, like that. We ended up with a semicolon. Oh no, so we're gonna multiply it again, and this time it's gonna be by the a vertex by the a vertex position. So position, like that. Okay, so we ended up with a semicolon, and now we close the curly braces. So let me see. Okay, so yeah, we close the curly braces, we close the backticks, and we ended up with a semicolon as we did. So yeah, that's what the code that we needed to do, and this is the vertex shader program. So we have that, and let's save it with Control S. Okay, so we have that, and if you go here, nothing's gonna happen yet. Okay, so eventually we're gonna have in some white square inside, but this is just the basics. We're gonna, okay, yeah, let me see. Okay, so it's worth noting that we are using a vec4 attribute for the vertex position, which doesn't actually use a 4 component vector. That is, it could be handled as the vec2 or vec3 depending on the situation, but when we do our math, we will be to we will need to be a vec4. So rather than convert it to a vec4 every time we do math, we will just use a vec4 from the beginning. This eliminates operations from every calculation we do in our shader. Performance matters. So in this example, we are not computing any lighting at all since we haven't yet applied any to the scene. That will come later in the example lighting and the WebGL. Note also that lack of any work with textures here. That will be adding and using textures in WebGL. Fragment shader. The fragment shader is called once for every pixel on each shape to be drawn. After the shapes vertices have been processed by the vertex shader, its job is to determine the color of the pixel by figuring out which texel, that is the pixel from within the shape's texture, to apply to the pixel, getting that texel's color when applying the appropriate lighting to the color. The color is then returned to the WebGL layer by storing it in the special variable GL_frag color. That color is then drawn to the screen in the correct position for the shape's corresponding pixel. So we have that, and let me see. Oops. Okay. Now, in this case, we are returning white every time since we are just drawing a white square with no lighting in use. So now we're gonna start adding more code to our JavaScript file. So we're gonna add this piece of code. We're gonna add this function. Okay, so add this to your code. Okay, so we're gonna go into our JavaScript file and we're gonna go let's go below the vertex shader, and now we are gonna have this variable. So we're gonna type in cons like that, and the name is gonna be fs like that, fs source. Okay, it's gonna be fs source, and camel notation, we're gonna set it to backticks. We ended up with semicolon, and inside of the backticks we're gonna type in our code. Okay, so here we're gonna have void, and it's gonna be main. We're gonna open close parentheses, and okay, outside of that we're gonna open curly braces, and we're gonna have the GL_position, GL_frag color. So it's gonna be like that. Okay, let me see. Yeah, it's gonna be frag color like this, and we're gonna set it to the vec4. Okay, and here we're gonna have in this by 1.0. Okay, it's gonna be 4 times, so we're gonna have a 1.0 separated by comma. Okay, and then 1.0, and finally 1.0. So we have that frag color, so it has to be with camel notation. Let me see. Okay, so yeah, we close the curly braces and we close the backticks. Okay, so that is that. Okay, so you need to save it with control S in my laptop since I'm using Windows. Okay, let's keep moving. So initializing the shaders. Now that we have defined the 2 shaders, we need to pass them to the WebGL, compile them and link them together. The code below creates the 2 shaders by calling load shader, passing the type and source for the shader. It then creates a program, attaches the shaders and links them together. If compiling or linking fails, the code displays an alert. Okay, if compiling or linking fails, the code displays an alert. Note, now add these 2 functions to your WebGL-demo.js. So again, right now we only have 1 JavaScript file, so that is that. So I'm just gonna grab the comment, and I'm gonna go into just below here. I'm gonna paste this comment. So initialize a shader program. So WebGL knows how to draw our data. So we have that. And now let's start typing in our code. So we're gonna have in a function. Okay, so we're gonna have in a function, and we're gonna name it init shader program. So okay, so it's gonna be init, okay, camel notation, shader, and then program like that. Init, okay, shader program. Okay, so and then we're gonna open parentheses, and we're gonna have in three parameters. We're gonna have three parameters. That is gonna be GL. The second is gonna be the VS. Okay, I have it right here, the VS source, and finally we're gonna have here the FS source. So we have that. We're gonna open curly braces, and now we're gonna have 1, 2, 3. Okay, so we're gonna have inside of the curly braces, we're gonna have in some variables. So now let's create it. Okay, let me see if we are missing something. No. Okay, so we're gonna create it. So we're gonna create this vertex shader. So it's gonna be vertex. Okay, it's gonna be vertex shader, and we're gonna set it. So we have the vertex shader, and we are gonna set it to the load shader. So it's gonna be load shader, like that, and we're gonna open parentheses, and inside of the load shader, inside of the parentheses of the load shader, we're gonna pass in this parameters. That is gonna be GL. It's gonna be GL that, and now in uppercase letter it's gonna be the vertex underscore shader. So vertex underscore shader, like that. Okay, so we have that. We're gonna have another parameter that is gonna be the VS source. So it's gonna be VS source. I have it here. Okay, so I have the GL that vertex underscore shader, GL that vertex underscore shader, and then we have the VS source, like that. So that's fine. Let me see what else do we have here. Okay, so we ended up with a semicolon. Sometimes it's not required like in MySQL, but let's do it. Now we're gonna create another one. We created the vertex shader. Now we're gonna create the fragment shader. So we're gonna go below here, and we're gonna create it's gonna be the fragment, like that, and it's gonna be shader, and we're gonna set it to, let me see, we're gonna set it to something. So we're gonna set it to the load shader, and again, let me see, it's pretty much gonna be it's gonna be similar. So we're gonna set it to load shader, and we're gonna pass in some parameters. It's gonna be GL, and then that, and it's gonna be vertex, and it's not gonna be vertex shader. Let me see, it's gonna be fragment shader. So yeah, it's gonna be fragment shader. Oops, uppercase. So it's gonna be fragment underscore shader, comma, and then we're gonna have the FS source, like that. We ended up with a semicolon at the end. So we have the VS source, we have the FS source. Okay, so now we're gonna create let's copy just the comments. We're gonna create the shader program. So we are still inside of this. Let me see if I can make it, maybe it's too big, like that. Yeah, that's fine, I guess. We are still inside of this init shader program. So now we're gonna create the shader program. Okay, so we're gonna create a shader program here, and we're gonna have, let me see, we're gonna have in the shader program, okay, like this. We're gonna have the counts, and it's gonna be the shader program. We're gonna set it to something, and we're gonna set it to the GL. We're gonna set it to the GL that it's gonna be create program. So like that, create program. We're gonna open close parentheses, ended up with the semicolon. So we have the counts shader program. We're gonna set it to GL that create program. Okay, that's fine. Now to the next line, we're gonna have GL that. So we're gonna have GL that attach shader. So it's gonna be attach shader and camel case notation. We're gonna open parentheses, and we're gonna have the shader program and the vertex program. So it's gonna be shader program, and also the vertex. Let me see, vertex, the vertex shader. So the vertex shader, like that. we have the GL that attach shader, we have the shader program, we have the vertex shader. Now we're gonna have the another GL that attach shader, and it's gonna be the same, but instead of vertex it's gonna be fragment. So let's just copy this and paste it below. So it's gonna be the GL that attach shader. We're gonna have the shader program, and now instead of vertex we're just gonna have fragment, like that. Fragment shader. Fragment shader. Let me see. Fragment. Okay, so it's gonna be like that. Fragment shader. So let me see if I made a mistake. Well, it's gonna tell me if I made a mistake. So yeah, we have the fragment shader. So now we're gonna move to the gl.link program. So we're gonna have gl.link program like this. Okay, so link program, shader program. So it's gonna be, let me see, shader program, like that. It's gonna be the shader program, and we're gonna end it with a semicolon as all of this. So let's end it with a semicolon. We have that. Okay, so now we have the gl.link program. So now we're gonna move to if creating. Okay, so let's copy just the comment and let's go below. So if creating the shader program fails, then we're gonna throw some alert. Okay, so we're gonna have the if statement. So it's gonna be if something, we're gonna do something. So if, let me see, if, and then we're gonna open curly braces after that, but inside of the parentheses of the if statement we're gonna have, okay, so exclamation mark, GL if not, GL that get program, that get program, if not, that GL that get program parameter. So parameter, like this, get program parameter. We're gonna have we're gonna open parentheses and we're gonna have shader program. So it's gonna be shader, it's gonna be shader program, like that. We're gonna have, this is the first parameter, the second is gonna be the gl.link status. So we're gonna have gl that in uppercase letters is gonna be link underscore status. So we have that gl.link status. And okay, so that's all we have. So if not, gl that get program parameters, shader program, gl link underscore status. So inside of this curly braces we're gonna start typing our code. Okay, so we're gonna have this alert, and I can, let's just type it in. So we are gonna have in just alert. Okay, so it's gonna be alert and lowercase letters, so it's gonna be alert. We're gonna open parentheses, and inside of this parentheses we're gonna have him backticks. Oops, we're gonna have him backticks. Okay, so let's just type it in. Okay, so we have this alert. So an error occur compiling the shaders. An error occur compiling the shaders, like that. And we're gonna have the column here. And okay, let me see, we're gonna have in this column, and to the next line we're gonna have in the dollar sign. We're gonna open curly braces again. Okay, and we are gonna, okay, so we're gonna separate this by a comma, since this is gonna be an argument. So inside of the curly braces of the dollar sign we're gonna have the gl dot, and it's gonna be get, okay, get shader. Okay, gl dot get shader info log. So get shader info, let me see, info log, like this. gl.get shader info log, and we're gonna pass in the shader. So we're gonna pass in the shader. Okay, and then we separate it with a comma here. Okay, so we can just close this parenthesis here, so I can move it maybe here like that, and then we ended up with a semicolon. So we have the comma, then we close the parenthesis, we ended up with a semicolon, and outside of that, outside of the semicolon, we're gonna have the gl dot. So we're gonna have the gl dot delete shader. So it's gonna be delete, okay, delete shader. We're gonna have the delete shader, and we're gonna pass in the shader like that. We're gonna end it up with a semicolon outside of the parentheses like that here. And let me see, we're gonna return null. So we're gonna return null like this, and we're gonna end it with a semicolon at the end. And this is the curly braces here that we're closing in. Okay, so out just before the this is the final curly braces. Just before the final curly braces, we're gonna return the shader. So it's gonna be a return shader, so like that. So we're gonna save it. So this is all the code that we just added, but nothing has changed obviously.